Hi everyone, I'm Cheryl. In this problem, we're going to be looking at a series that is represented with the sum from n equals 0 to infinity of minus 1 to the n times 5 all over n factorial. We want to look at the first 6 terms of this series to get an approximation for the sum. To begin, we're going to take a look at the series and first verify that it does indeed converge to a number. This particular series is what we call an alternating series. And if you ignore the part that alternates the positive and negative 1, and I just look at the 5 divided by n factorial, I want to make sure, first of all, that those terms are positive. And then I need to look at 2 things. The first item that I need to look at is I want to make sure that the limit as n approaches infinity of 5 divided by n factorial equals 0. And in fact, as n approaches infinity, n factorial gets very large as well, and 5 divided by a very large number does in fact equal 0. So my first condition is true. The second thing that has to happen is that the a sub n term has to be greater than or equal to a sub n plus 1. All right, so let's see what happens in this particular case. Let's start with something I know. I know that n is definitely less than or equal to n plus 1, which means that n factorial is definitely less than or equal to n plus 1 factorial, which means that 1 over n factorial is greater than or equal to 1 over n plus 1 factorial, because we're taking the reciprocal. And then if I multiply both sides by 5, 5 over n factorial is definitely greater than or equal to 5 over n plus 1 factorial. And what have I shown? I've shown that the nth term is greater than or equal to the n plus first term. So this condition holds as well, which means that my series is a convergent series. Okay, now let's go ahead and take a look at the first 6 terms of that series to get an approximation for the sum. So to do that, I really just let n start out being equal to 0. So I'll have minus 1 to the 0 power times 5 all over 0 factorial. That's my first term. I'll add that to minus 1 to the first power times 5 all over 1 factorial. Then I'll add minus 1 squared all over 5, or times 5, all over 2 factorial, plus minus 1 to the third power times 5 all over 3 factorial, plus minus 1 to the fourth power times 5 all over 4 factorial, plus a minus 1 to the fifth power times 5 all over 5 factorial. Now let me just check here. 1, 2, 3, 4, 5, 6. I have 6 terms. So now I can do some simplifying. Negative 1 to the 0 is 1 times 5. 0 factorial is also 1. So this will be a 5. This will be a minus 1 times 5 all over 1 factorial. So we'll write that as a minus 5. The next term, negative 1 squared, is a positive 1, and we've got 5 over 2 factorial. 2 factorial is 2, so that's going to be plus 5 halves. The next piece is negative 1 times 5 over 3 factorial. So that will be adding a negative 5 sixths, because 3 factorial is 6. The next piece, negative 1 to the fourth power is a 1. My numerator is a 5. And 4 factorial is 24. And then the last piece, negative 1 to the fifth, that's a minus 1 times 5. So I've got a minus 5. All over 5 factorial, which is 120. If we do the arithmetic here, we end up with 11/6 for my sum. Okay, now that's not the exact sum because that's only the first 6 terms. So what I want to do next is use the alternating series remainder theorem to help me figure out how accurate my answer is. So I know that when I take the remainder, or the difference between the actual sum and my approximation, when I'm using an alternating series, that remainder will always be less than or equal to the n plus first term. In this particular case, we were using 6 terms. So the remainder, after using 6 terms, is going to be less than or equal to the 7th term in my series. Now, what would that 7th term be? Well, it would be minus 1. The next term, this is the 6th term, remember, so that would be minus 1 to the 6th power times 5 all over 6 factorial. It might seem a little odd that it's the 6th power and 6 factorial and it's the 7th term, but remember we started with the 0th term. Okay, so if you calculate this, minus 1 to the 6th power is obviously just 1, and we'll have 5 over 6 factorial. That turns out to be 1 over 144 when you do the arithmetic. Okay, so what does that mean? Well, I know that the absolute value of my sum minus, and in this case, I'm going to be using my 6 terms, is going to be less than or equal to 1 over 144. So what does that tell me? Well, that tells me that my sum minus my approximation is somewhere between minus 1 over 144 and positive 1 over 144. And I know what that approximation is. It's 11/6. So S minus 11/6 is somewhere between minus 1 over 144 and positive 1 over 144. So my actual answer, my sum, is somewhere between 11 over 6 minus 1 over 144 and 11 over 6 plus 1 over 144. And if you use a calculator here, you can find out, getting a common denominator, that this is 264 over 144. So this reduces to 263 all over 144. And over here, we're going to have 265 all over 144. So I know that the actual sum to this infinite series is somewhere between those two values. I hope that was helpful. Thanks.